Okay guys, since making a video on this antenna, this is a high power end-fed half wave and the transformer has been wound in the Autotransformer method. I've had some questions from people asking how do you actually wind this transformer, and I've actually looked on YouTube and I don't see any videos actually in particular relating how to wind an Autotransformer. So in this video that's what I'm going to do. So there's certain times you may want to use a transformer, and my use case is to have an efficient high power end-fed half wave. So it may not always be the case that you want to wind an end-fed half wave transformer, but that's what we're going to do. So this is actually a stack of FT240 43s. Back in here is that these are actually FT240 52s, but dimensionally they are the same, so that's what I'm actually going to show you. Now, the wire that we're going to be using is 1.18 millimeter wire. So there's two reasons for that. I only have this wire and it's actually not too bad to wind. On the other transformer it was 2 and a bit millimeter wire, really hard on the hands. Now I have a piece of wire which has been cut already. So this is 1.7 meters long. I'm not sure what that is in old money, but I'll put that on the screen. So what do we actually need to do first? Well, I'm actually going to put a bend on this, and you could use absolutely anything here. So imagine this is going to be your tail to your ground or your shield of your end-fed half wave. So I'm actually just going to put a little bend on it like so. Just so we get a right angle, 90 degrees. And then we're going to get our core, and we're actually going to start winding this. So this is in some ways is much easier than actually winding a twisted primary, the sort of standard end-fed half wave that you see everyone using, which is still a very good method. It's just horses for courses. So we want to start winding our core. So that would be one turn because the wire has went once through the center of the core. We want to keep that very tight. Again, it's hard to actually show you here. Putting it through here. Now, I'm going to continue this till we have 14 turns. So that's 14 turns through the center. Now, as you see, as I'm doing this, I'm keeping the turns very close together. Now, before I go any further, I just want to count the turns. I'm just going to count them on this side. That's 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. That's 1, 2, 3. 13, one more turn. 14. Again, it turns through the center. We're going to fold that up, and we're just going to fold this wire. Now it depends on your application, but I'm just going to fold that in the same position as just so it's in the middle like the first wire. So there we go. We've now got our 14 turns of enamelled copper wire, and now we need to do something called tapping it. And this is actually an old one here. So we need to solder on a piece of wire, and that'll go to the center conductor of our SO239, so that would be the center of the coax that it goes to. So I'm just going to trim this down a little bit, like so, and I'm going to trim this down like so. So I'm actually going to use this little bit of wire here, and I'm going to bend it. But before I bend it, I need to actually scrape the enamel off here. This is quite tenacious stuff, so I just like using Stanley blade, like so. You could use sandpaper, you could use a Dremel, whatever. Some wire, you can just heat it up and it's solderable once it gets to a certain heat, but I like to scrape it off. There we go, nice and shiny. I don't know if that's just the light. Okay. So then what we need to do, it's actually better bending it after, so I'm just going to bend that at 90 degrees, like so. Okay. So we're actually going to solder that onto our wire, like that. Okay. So, where are we actually going to do that? We're actually going to do that, what's on here is on the third turn, so it's after the second turn. So that would be 1 turn, 2 turn here. On the third, as you see it here, this one here. Now you need to be careful with this, but what I like to do is just spread the wires out. So it's that one in the middle that we're going to be doing. And just to be safe, this is expensive tape, this is Coroplast, I can't find my cheap stuff, but I'm just going to mask the wires that we're not working with. And the reason for that is, well, we don't want to accidentally scrape the enamel off those, do we? So, I'm talking from experience here. Okay, now, so we've got our wire here, and we need to say, well, where are we going to solder it about? I'm saying weld. So we need to know roughly where we want. I'm just going to mark that with my thumb. You could do this, you could mark it with tape if need be. And I'm just going to start scraping. You could tap this before you wind it, that is a possibility. But I'm just doing it like this. And I think I actually prefer doing this to doing the old method of the twisted primaries. Don't need to scrape all the way around about the wire. It's not looking bad at all. Like so. Okay, now we need to get soldering iron out. I could take off our masking there. We can actually still keep the wires spread out a bit there. So this is a Super Pro 125. It's made under various different brand names, but it's first class. It's not really ideal for circuit boards, but see, for things like this, absolutely perfect. RF connectors, and as I don't really do any PCB soldering, it's absolutely ideal. So I'm just going to let that heat up for a minute. I'm using leaded solder here. This is Weller solder. I just get this from Amazon, and I just want to tin this. Now, these cores are actually just taped together. If you were doing this, you would have them super glued. Just that I'm going to separate them again. And see how quickly that actually solders tins, like so. So now we need to solder one to the other. It's going to be hard to show you here in the light. I'm trying to do this suboptimal. It's not perfect, but for a demonstration it will do. Turn the soldering iron off, put it to the side. So we will let that cool, and I'll actually go quite strong. I mean, there's not going to be any real force on that anyway. So that in effect is our Autotransformer wound. Now I'm just going to trim these wires like so. So what you've got here is, so this would be your ground to your SO239 B and C coax shield. This would go to the center of your coax, your center of your SO239 B and C, whatever. And this end would then go to your antenna. Now I've actually reversed it on this example. So instead of being like this, it's actually like this. So it's still the one on the outside that's went to the ground. The tapped wire, which is actually went to the center of the SO239, and the other end which is went to the antenna. So I do recommend that you use a capacitor. So that's a 3 kilovolt TDK 100 picofarad capacitor. So there we go, folks. That's actually it, and relatively simple. So it's horses for courses, depending on your needs, whether you want to wind a auto transformer or not. That's how you do it. Alright guys, hope that was of some use. 73, all the best, and we'll catch you on the next one. Bye for now.